Hi, my name is Nathan Mullin, and this is the presentation of my final year project. For my final year project, I chose to do an automated car part system. Why we chose this as our project? We chose the automated car part system as our project because it is a simple yet innovative creation that relieves the tedious and boring job of allowing cars into a parking lot, keeping count of the spaces left. This was also one of the previous exercises we had done online, which impacted our decision to make this our project. Our project is a miniature model of an already existing piece of technology. It has a motor, boom arm, and stands. It also contains a circuit board, which holds the motor reversing circuit, and another, which the PLC hardware is for. Our model is fully functional and capable of lifting, pausing to allow entrance, and lowering of the boom. On the next side, we will go through the components needed to make the motor reversing circuit and some specifications of these components. In building our motor reversing circuit, we use three 100 ohm resistors, 2 in parallel and 1 in series, to create a total of 150 ohms. A 16 volt DC motor, two 5 volt relays with nominal operating current of 40 milliamps and a car resistance of 120 ohms. The three resistors were used to lower the 12 volt supply to 5 volts DC to operate the relays. This is an image of the PLC we use to automate our system. What is a PLC? PLC stands for Programmable Logic Control. PLC is an electronic device used in the automation of electrical devices. PLC programming is an important task of designing and implementing control applications. The program consists of either textual or graphical instructions, which represents the logic to be implemented for specific real-time applications. Software is often written on a computer using the ladder logic. This is a short video of our system in operation. The system is an automated car part entrance and the sensor for the exit. The sensors are emulated by buttons, and when the entrance sensor is pressed, the boom raises for 2 milliseconds, pauses for 10 milliseconds, closes in 1 millisecond. When the car is max capacity, cars need to exit on the other end passing the other sensor, allowing other cars to enter. The count of spaces is controlled by a counter. The boom registers a negative count from 6 down to 0, and the exit sensor registers a positive count, adding 1 free space every time a car exits from that site. What we demonstrated above was how a car enters and exits an automated parking system. When a car approaches the car park, the boom will raise, stay elevated for a short space of time, and then lower due to the timers that were used in the system. Counters were also used to count the empty car spaces of the car park when the car entered or exited the car park. We'd like to thank Mr. Helly, our electrical tutor, and Mr. Nichols, the lab assistant, since they were so helpful throughout the whole process of our project. That brings us to the end of this presentation. Thank you for your time.